Chemistry is a science for the 21st century. Chemistry is involved in so many different things. This gives you some idea. Health and medicine, sanitation systems, surgery with anesthesia. Without anesthesia, there would be no surgery. Vaccines and antibiotics, gene therapy, all the stuff that we have today. Energy in the environment, different types of fuels, materials and technology, polymers, ceramics, all the stuff that you have at home, the clothes you wear, the computer that you're using, all this stuff is involved in materials, and chemistry is vital to the production of those. Now, in the study of chemistry, we go from the macroscopic, which means what we can see, and we try to interpret what's happening on the microscopic or the atomic level. So we have to make up models to picture what we think things are really like. Even though they might not be exactly like this, it just helps us to get a better view of what's going on. Now, we use a scientific method in problem solving, and this is an example of that. First of all, we have to make observations. Observations can be qualitative or quantitative, meaning you could say something like a person was 6 feet tall. That would be quantitative. Or you can just say the person was tall. That would be qualitative. They can sometimes try to make you come up with a better observation. So you might say, can you qualify that observation? So you might say, well, somebody is taller than me, and that helps to narrow that down. So we have observations, and then we have what they call representation. This is where we try to figure out exactly what's going on there. We might make hypotheses, and then test our hypotheses, and then we try to interpret them. And the arrows show you that this process is ongoing, on and on and on. So a hypothesis, which really means little idea, is a tentative explanation for a set of observations. A tentative means it might not be a true explanation, but we always have to test it. So we test it, and we can modify that hypothesis, and we can change it all the time. So hypothesis is not the same as a theory. A law, on the other hand, is a concise statement of a relationship between phenomena that's always the same under the same conditions. Laws many times are mathematical. Now here's an example of one. Force equals mass times acceleration. Now this doesn't explain what's going on, but it's a statement which we could then say is an equation and use it to calculate the force that is necessary to, let's say, to accelerate a particle with a certain mass. In chemistry, you're going to learn a lot of gas laws. We have things like Boyle's law, Charles' law, law of Gay-Lussac, Avogadro's law, and all of those will have little formulas with them. A theory, on the other hand, is an explanation. So it explains everything that we have seen, and it also should be able to predict what we will see in the future. Now, theories also come and go, so a theory is really best written with pencil. Now, here's an example. Here we have the atomic theory. The atomic theory explains about rusting. And we have our oxygen molecules here, we have our iron atoms down here, and then we have what we feel is the formula for rust. This Fe2O3. So that's our interpretation of it. But even the atomic theory has changed over time. It's had about 6 different things added to it and taken away from it. Now, chemistry in action. This is right out of the text. In chemistry in action, here we see primordial helium and the Big Bang theory. So, 1940, George Gamow hypothesized that the universe began with a gigantic explosion or a Big Bang. Now, he hypothesized it, meaning he said that's how it began. But we have to have some evidence for it. So, what are these experimental evidence? The universe is expanding. And they can see that the universe is expanding because of the radiation that's being produced. The radiation that's being produced tells us that things are moving further away from each other. If you go backwards then, you can come up with a spot where everything was all together. And then right after that, it exploded.